So your finished CanSat will probably look something like this. Some kind of parachute, your circuitry mounted, installed inside a can. So for strength and stability, the electronics part is mounted on this aluminium plate, which has been bent into shape. The eye bolt up here is used to attach the parachute. Now you're free to design this structure in any way that you see fit. So there are some ideas on the slides and in the manual. Now you'll see that the electronics part is actually made up of two boards, the Arduino with another board mounted on top. This second board holds our sensors for the primary mission and will hold any extra circuitry that you put in for your secondary mission. I can take these apart because I'd like to show you how this is made up. So I'm going to separate them out. So that's, you call it a daughter board, okay? And it's the motherboard. Separate them out. This is the Arduino as came in your kit. And now we'll have a look at how you might put this together. So I'd like to show you how to put all of this together. Now don't connect or solder anything up permanently until later in the project when you've tested your circuits on breadboard and are confident that you have space for any components you plan to use for the secondary mission. But we'll go ahead and show you how to do it now. Now in your kit you have this PCB, you have the connectors, we have our sensors and the radio module. In order to fit the components neatly inside the can, we'll use this printed circuit board from AAU in Denmark. Instead of wires between the components, a PCB uses layers of printed conductors or metals. Using a PCB will save space and keep everything in its correct position. The circuits will be robust, but more difficult to change than with the solderless breadboards. To connect the AAU PCB, we first need to solder headers onto the PCB. These things here. That will allow us to connect this board onto the Arduino. So I'm going to have to cut this into 4 pieces. 1 6-pin, 2 8-pin and 1 10-pin length. Okay, so 1 6, 2, 3, 4, 5, 6. Actually I can just break them. 2 8s, so that's 2, 4, 6, 8. 2, 4, 6, 8. And a 10. 2, 4, 6, 8, 10. Now these get inserted like this. 2 8s there and there. Shorter pin into the board. And I'm going to flip those over and solder them into position. Now I've soldered those header pins in. So this now is possible to be connected onto the Arduino like this. Right. Next, solder in the thermistor, its resistor, the leads for the battery, and a jumper wire at J2. This jumper is used to configure the radio unit. Now, this board shows where I've soldered in the thermistor and its resistor here. I've soldered in the clip for the battery onto the 2 pins here. And then we've put in sockets so that the pressure sensor can be slotted in and out rather than soldering it directly. And that way, if there's any problems with it, we can easily remove it from the board or add it in. This area here, again, I've soldered in another socket. You'll have to cut this socket to the correct length, and I have a 2-pin one down here. We're going to use this to mount the radio module. Pins go in here. I've also soldered 2 little pins at the top of the radio module just for physical support. So those 2 get soldered in there, socket here, and the module can just sit into the sockets, like so. That's the completed daughter board for the primary mission. Still room underneath here and here for any extra circuitry you might design in for your secondary mission. So that's the basic module constructed. You can see there are free sockets on the AAU board, even some under the radio module. This space could be used for your secondary mission circuitry. On the finished CanSat, a thread antenna is used instead of the rigid one from the kit. This will connect on here. It's lighter and more robust. There are details on how to construct the thread antenna in the manual and in some of the other documentation in the GMIT CanSat Dropbox.